Good morning. It's Monday, July 8th, 2013. Welcome to Houston, and this is Mission Control Houston. You're looking at the International Space Station Flight Control Room, a wide shot, looking over the top of the consoles of the flight controllers that work around the clock on 3 shifts, supporting activities aboard the International Space Station with their focus on the U.S. operating system of the orbiting complex. The team throughout the day is being led by veteran Flight Director David Korth. He and his team have been on console since about 7 o'clock this morning. He is joined by astronaut Megan Benkin. She served on the Hubble Space Telescope final servicing mission as a mission specialist on STS-125, the flight of Atlantis. She is serving as the communication link between this team and the crew aboard the International Space Station. The ISS, or International Space Station, is currently beginning a northeasterly track on the dark side of the Earth as it approaches the northeastern coastline, skirting the coastline of New Zealand on a orbital period of about 92 minutes, meaning it circles the Earth every 92 minutes from this altitude of 250 statute miles. Approaching the next coastal crossing will be the coast of the United States in about 20 minutes, traveling about 5 miles per second. The station is housing the Expedition 36 crew, which of course is a 6-member crew aboard the complex. They are dividing and conquering aboard the station, if you will, today. The Russian segment being housed primarily by the 3 Russian crew members on board: Commander Pavel Vinogradov, Alexander Mazurkin, and Fyodor Yurchikhin. Those 3 primarily focus their attention in the Russian segment of the station. Over in the U.S. segment are Chris Cassidy, Karen Nyberg, and Luca Parmitano. Parmitano as representing the European Space Agency as a member of the Italian Space Agency aboard the station. It's his first flight. He is actually the 209th individual crew member to live aboard the International Space Station. That 6-member crew is split into 2 groups. The 34 Soyuz crew, Pavel Vinogradov, Alexander Mazurkin, and Chris Cassidy, have been aboard the station now for 102 days since their launch. They launched to the complex back on March 28th, and they plan to return home on September 11th. The other 3 crew members are considered the newest crew members, Yurchikhin, Parmitano, and Nyberg. They are in their 41st day in space and aboard the International Space Station, having launched on their 35 Soyuz spacecraft back on May 28th. They plan to be aboard the station until November 10th. Several of the crew members pretty much have been focusing their attention on preparations for a spacewalk Tuesday. The crew members have done an extensive amount of work in checking out their spacesuits and also their tools and equipment that will be used for that spacewalk, that will be performed by Chris Cassidy and Luca Parmitano. Cassidy will be performing his 5th spacewalk and Parmitano his 1st. So those 2 crew members, with assistance from Karen Nyberg and Fyodor Yurchikhin, have been working with primarily focusing their attention in the U.S. airlock quest to prepare for that spacewalk, which is scheduled to begin Tuesday morning a little after 7 a.m. Central, 8 o'clock Eastern Time. In and around that activity, there is quite a number of experiment work that's going on, a lot of which can be done robotically or remotely from the ground, basically a telework type format for the experimenters on the ground to watch over experiments. The crew members do get involved quite a bit in experiment checks throughout the day and the week as they perform other duties as assigned aboard the station as well. So a busy day for the crew as they come out of the weekend and head into their Monday morning aboard the International Space Station, preparing for Tuesday's EVA or spacewalk. the EVA that Cassidy and Parmitano will perform Tuesday. We'll focus on the 2 crew members replacing a space-to-ground communications receiver, also a wireless video equipment associated with the video system of the International Space Station, and install power and cables for a future Russian science module known as the Multipurpose Laboratory Module that will be launched by its schedule later this year. That new module will serve as a research facility aboard the station, and also as a docking port and airlock for any future Russian spacewalks. It is scheduled and designed to replace the Pirs module, which is the docking compartment or DC-1 module that was launched back in September of 2001. There's also a number of other tasks that you saw there that the 2 crew members will perform throughout that planned 6.5-hour-long spacewalk. Of course, we plan to cover the spacewalk end-to-end beginning at 6 a.m. Central, 7 o'clock Eastern Time with our coverage, and then that will obviously lead toward the start of the spacewalk, which is signified by the switch of the extravehicular mobility units or spacesuits that the 2 crew members wear, switching their suits from internal power, station power, to battery power in the suits. That essentially starts the EVA clock. As part of just about any EVA, there's an extensive amount of robotic support as well for the spacewalks, and tomorrow's Tuesday spacewalk is no different. On console right now, as part of the current team, is Laura Lucier. She is the robotics flight controller, and she actually will be on console tomorrow. In just a few minutes, at about 10:30, she's going to take an opportunity to step over here to the Public Affairs console, and we'll have a little chat about her duties associated with that console, and also specifically about the spacewalk and her involvement with the robotics work associated with the EVA that Cassidy and Parmitano will perform. So we'll look forward to chatting with Laura here in just a few minutes. The last U.S. airlock or Quest airlock EVA was performed back on Expedition 35 back in May, middle of May, by Cassidy and Tom Marshburn. Since that time, of course, Russian crew members Fyodor Yurchik and Alexander Mazurkin performed a spacewalk just a couple of weeks ago on June 24th. But the spacewalk tomorrow will be using the U.S. spacesuits. Chris Cassidy will serve as EV-1, extravehicular 1, and Parmitano will serve as EV-2. Cassidy will be designated by the markings on his spacesuits that will bear a red stripe, typically up on the shoulders or on the backpack of the suit, and also on the upper thigh area of their lower suit. And Parmitano will wear a spacesuit that essentially looks like it's all white. The stripes actually are on the suit, but they are white, so they match the color of the suit. So that's how the 2 crew members will be. You'll be able to tell which crew member is which during the spacewalk.
Question. I don't believe that we have anything specific. But it is not like we're running around with our hair on fire, because I was just commenting to my doctor team there that it's 3:10 in the afternoon and we're done with EVA prep, and it's not like any other EVA feeling I've had before. So that's a long answer for we've got the time, and we're happy to meet with him if he'd like to. It's no problem.
Okay, that's got to be a great feeling to be having that time. We'll talk to him one more time and get back to you.
Okay, so maybe you can phrase it, if he needs that time back, he's welcome to have it.
Okay, we'll do that, Chris. Also, while I have you, do you know if Karen and Luca are planning to also use SSC-15?
Yeah, just make it that be the standard, and I'll leave it set up to automatically accept.
Sounds good. Thanks.
Megan Benkin talking to Chris Cassidy relative to the activities associated with EVA preparation. The crew members, in addition to their normal timelined activities, periodically have private medical conferences with flight surgeons here on the ground, and especially ahead of spacewalks. And he did just complete his private medical conference prior to tomorrow's EVA. More than likely they'll have one more chat in the early hours before they start suit up tomorrow morning or Tuesday for the spacewalk. With the crew day beginning at 1 a.m. each day Central Time, their EVA spacewalk planning activities will begin fairly quickly after the crew gets through its morning activities, which usually covers the first couple of hours of the crew's day. After the crew wakes up every day, they have a daily planning conference with flight control teams around the world, typically about an hour or so after wake up. That will essentially allow the crew members to look at their timeline for the day and talk about any activities that may be unplanned on their schedule. And then they'll also have a daily planning conference at the end of the day each day to wrap up the day and look ahead toward the following day. And of course, today's daily planning conference that occurred at 2 a.m. Central Time essentially reviewed their timeline for the day, which for most of the U.S. operating system crew members, that includes Cassidy, Nyberg, and Parmitano, focused on EVA preparation work, including health status for the crew members that performed and checked on board by the crew medical officer, which in this case is Karen Nyberg. She also helped with EVA tool configuration activities earlier in the day, and an audit of all of the tools that the two crew members will use throughout the spacewalk tomorrow. When the airlock hatch essentially closes in the crew lock portion of the airlock, essentially the crew members have to have everything with them that they'll need for that spacewalk. And there's also, of course, tool bags on the outside of the station, so they can access equipment on the outside as well once they get out the hatch. The crew members had an onboard procedural review for the EVA as well early Monday, and then about an hour ago they had a conversation with the EVA team on the ground as well as the robotics team to also collectively with the flight control team go over the EVA procedures as well. So the preparation for an EVA is fairly extensive to ensure that everybody is essentially on the same page with all of the activities, the training, a lot of which is generic training that was performed on the ground before the crew members ever even flew. So they are well versed in the EVA procedures, and of course the flight controllers that they're working with now long distance, they worked with up close and personal here on the ground before their training template ended before launch.
Петр Николаевич, есть какие-то изменения или что-то еще?
Do you have anything to report?
Нет, все
No, everything has been completed. I left that quite the same way.
The best way to describe the plans for the EVA is to do that with the actual folks that went into the planning, performed all of the planning tasks here on the ground, and Ernie Bell, who will serve as the lead EVA officer here in the room, talked about tomorrow's EVA in detail and during a press conference recently. So let's take a look and listen to what's in store for this EVA scheduled for Tuesday.
We'll start out EVA 22. Chris is going to be wearing the red stripes. He's going to be egressing first, and he's going to do so with the spare space-to-ground transmitter receiver controller. Luca Parmitano, then, he's going to be wearing the plane suit, will egress second, and he'll take with him a cover for one of the Missy experiments, the Ormate. So the first task for Chris, he'll translate aft on the airlock and up to the top of Z1, and he's going to get in position to replace the failed SGTRC. So he'll first stow the bag with the replacement SGTRC on top of the Z1 truss. He'll set up a temporary hardware stanchion, which he'll then attach the spare SGTRC to. So he retrieves it and places it on top. He'll then move over to the failed unit and get in position to release it via 3 bolts. Here you actually see a picture of Chris in the neutral buoyancy lab practicing this actual procedure. Once he's removed the failed one, he'll grab the spare and install it into the same location. And once complete, he'll stow the failed inside the bag, place the hardware stanchion inside the bag, and close it up. Once complete with the task, he'll return to the airlock where he'll stow this entire bag inside. Now, while Chris has been working on the SGTRC, Luca has translated up the CETA spur to the outboard side starboard truss to the Express Logistics Carrier number 2, where the Missy experiment is located. This actually includes 2 items, the optical reflector materials experiment, or the Ormate, and the payload experiment container, the PEC. So he'll get up onto position there on the forward zenith side of ELC2. And first thing he'll do is take some pictures of the material experiment. He'll also look over at inboard and take some photos of the AMS. Put a cover on the Ormate, remove it, and place it on his mini workstation. He'll then close the PEC, where the experiment was actually inside of it now. And here's a photo of the experiment on orbit, so you can see the hardware. He'll demate 2 cables from the PEC and connect them to the base. At this point, he'll release the PEC payload and stow it on his body restraint tether and translate back to the airlock. At the airlock, he'll actually stow both the Ormate and the PEC inside, and we can expect both the crew to be back at the airlock together at about this time. They'll then begin their next task, which is a starboard radiator grapple bar install. For this, Chris will translate up to the starboard CETA cart with a large RU bag that he's going to use for some flight support equipment brackets that he'll later remove from the RGBs. So he'll place this bag on the CETA cart. He's going to actually take out a large or a handling device, go up onto the mobile base system, and place this handling fixture or scoop onto the mass camera. This is for use later by Luca. He'll then go back to the CETA cart. Meanwhile, Luca has been retrieving a foot restraint. He'll actually gather this from the forward side of the external stowage platform number 2. He'll put on his BRT and then translate out port, just slightly port of where Chris has been working, where he'll begin steps to ingress the arm. So once he's on location, he'll put the foot restraint at the end of the arm, and then he'll ingress the foot restraint. At which point Karen is going to fly him over and get him in position where he'll be able to take control of the first of 2 RGBs. Meanwhile, Chris is moving around, breaking torque on the 4 bolts that hold this first RGB to the second one. On the forward side there, you see him, he'll release 2 bolts, translate around onto the second RGB, and then move back inboard so that Luca can move into position to take control of this first RGB. Once Luca takes control of it, Chris will release the second 2 bolts. Karen will fly Luca out, and Luca will then reposition the RGB into a better attitude for installation over on the starboard thermal radiator rotary joint, or the targe. And this arm maneuver here is going to be about a 15-minute maneuver. So he'll fly up over the station and get into position. Now during this maneuver, Chris is actually going to remove the 2 flight support equipment brackets that were used to hold the 2 RGBs together. He'll stow them back in the large ORU bag, which is over there on the seated cart. There's the first one, and now working on the second one. Once he has those both removed, he's going to translate outboard on the starboard side of the truss, and he'll meet up with Luca for the installation of this first RGB. So once in position, the 2 of them will work together to align the RGB on the stow bolts, on the stow beams. See there, and then they will iteratively work back and forth to secure the 2 bolts to mount that to the targe. Here's a photo from the neutral buoyancy lab of this task taking place. Once complete, Luke will be flown back towards the second RGB, which is still located at the POA. During the maneuver, Chris is actually going to translate back towards the airlock. And once he gets down to the airlock, he'll translate to the zenith forward high pressure gas tank. And here he'll retrieve the MLM power cable. This was previously staged there by Sonny Williams on EVA 18. The task here is to route the cable along the starboard side of node 1 and onto the PMA-1, or pressurized mating adapter number 1, on the aft side of node 1. Once Chris gets this task complete, he's going to translate back towards the port seated cart where he was earlier to help with the release of the second RGB from the POA. But first, Luca, on the flight over to the second RGB, is going to be brought in to remove a failed mass camera on the MBS. He'll drive a single bolt. That'll release that camera, and then Karen will fly him away and the rest of the way over to the second RGB. And once he's in position, he'll actually hand the camera off to Chris. Chris will then retreat aft near the seated cart. Luca will take control of the RGB. Chris will help work clearances, and they'll fly him out away from the POA. Again, Luca will rotate the RGB for the installation, this time over on the port targe. This flight here is actually about a 27-minute maneuver, so it's a pretty long arm maneuver. So there is, again, some time for Chris to go and work some other tasks. During this flight, then, Chris will return to the airlock, drop off the failed camera, grab two bags, one being a PMA-2 cover bag and the other a crew lock bag. We'll translate out to the forward end of the station where PMA-2 is and drop off the PMA-2 cover bag. He's not going to install the cover yet, but he will stage the bag. At this point, he's going to begin translating back to the port targe. Along the way, he'll drop off his crew lock bag. It's for use later with the Z1 Y bypass cable task. We'll translate the rest of the way out to the port targe. And timing working out, Luca will be arriving right around this time. So they'll again work together to stow this RGB in the same fashion that they did the first one. They'll work to align it onto the stow beams and then take turns iteratively driving the two bolts to secure it to the targe beam. At this point, Luca will be flown back to the same location where he ingressed the arm. It's about a 13-minute maneuver. A slightly different orientation, but essentially the same location. He'll egress the foot restraint and then remove the foot restraint from the arm and take it back down to ESP2 where he retrieved it from earlier in the EVA. At this point, Chris has translated back, picked up his crew lock bag, and is heading around to the aft side of Node 1 to a bag there called auxiliary bag number 1, where he's going to retrieve the two cables for the Z1 Y bypass task. So we retrieve those two cables and translate up over the top of Node 1 to the port side of the Z1 truss segment. Once he gets onto work site, first thing he's going to need to do is to reorient a foot restraint out of the way, and then he'll stage his crew lock bag. There's just a few tools and caps and such for the cable task. And then he will work the cable installs. He'll actually do a complete install of the Nader cable or the 4 Bravo cable. He'll do a partial install of the 3 Bravo cable or the Zenith one. That one's actually going to be completed on EVA 23. At this point, he returns to the airlock and stows the crew lock bag. At this point is another sync point for the crew where they'll both translate forward on station out to the PMA-2 location, where they'll work in conjunction to install the PMA-2 cover around the forward end of the PMA-2. There's basically a number of Velcro straps that they're going to cinch down onto the handrails around the circumference. One of the crew members then will pick up the PMA-2 cover bag, translate back to the airlock. This bag will be stowed inside the airlock and brought inside at ingress. The other crew member is actually going to translate back to the port CETA cart where the large RU bag, which contains those FSE brackets, is going to pick up that bag and then take it down to the airlock. Now this bag actually won't be brought inside on this EVA. The airlock's getting pretty full, so instead the crew is going to stow it on the starboard end there of the airlock. See right there where the handrails are flashing, and now place the bag there. Once it's complete, Luca will ingress first, Chris will ingress second, close the hatch, and this will complete the EVA-2 tasks.
Well, welcome back inside Mission Control. You're now close up at the Public Affairs Console, and as I mentioned a few minutes ago, Laura Lucier, who is the robotics officer, is actually on console all day today. And, of course, she's keenly interested in all of the activities associated with the robotic arm of the station, Canadarm2, but also, of course, the EVA that you just saw Ernie Bell describe as part of his press conference a week or so ago. So, Laura, thanks a lot for stepping off over there and coming over here and joining us. I appreciate it.
My pleasure, Kyle. It's always nice to have a little break.
Well, I was describing earlier, you know, the robotics function is integral to just about every spacewalk. But you guys have a very big task associated with this flight, but it's no better to hear from the experts. So, and of course, you've been here. You sent me a note. You've been here 11 years now. Have you been a front room? How long have you been front room flight controller?
I've been a front room flight controller since, oh boy, you put me on the spot there, 4 or 5 years now.
So no stranger to what happens in the front room, and of course everybody has backroom support. But talk a little bit about specifically what this EVA has in store for you guys, and there's some little nuances that we'll talk about too. But talk to me about what you guys have planned for tomorrow.
Well, for those of you who are just watching the EVA briefing video overview, you saw the animations of what we'll be doing. And the big thing about Canadarm2 is it gives the EVA crew a good stable work platform. So if they need to reach things that otherwise they couldn't easily reach, or in this case, maneuver a big piece of hardware. So we've got these two big grapple bars. They need to be moved from the payload ORU accommodation, or the POA as we call it,
right,
taken off of there and moved to their permanent stow locations on the ISS truss. So those are big pieces of hardware. They're tough to move around. So we're going to put Luca on the end of the arm, and we'll be able to use the arm to help maneuver him while he's holding those big pieces of hardware into position.
Do you, when you have a new crew member like Luca is, of course I assume y'all all worked together before they even launched. So when you have a new crew member, you tend to train with that person on the end of the arm for stability, just for maybe for familiarization. But once they get past that, like their second or third EVA, they may be a free floater. That's what I've seen in the past. Is that kind of how that was planned for him, or does it matter?
I don't know what decision making went into this specific EVA. Certainly, free float tasks have their own complexities,
especially because of the size of the ORU that you mentioned.
Absolutely, and moving on the arm also has its own nuances. In particular, one of the big things is the coordination and the communication between the arm operator, who will be Karen inside, and Luca on the end of the arm. They have to make sure that they've rehearsed all of their communication, all their coordination. There'll be points during the EVA where Luca will be asking Karen, okay, move me 1 meter to my left, or 2 meters forward, or backwards, or to the side. And so all of those calls and communications are what we really rehearse ahead of time, and we need to make sure our crew members are working well together on all of that.
Now, you mentioned the ORUs. You have a couple of images. I don't know if you want to talk to those now, but there's your first one.
Yes, that's right. And here you can see this is kind of just a screenshot similar to the briefing overview animations that I know you guys have been showing recently. And this is a picture of, an animated picture of Luca on the end of the arm reaching out to grab those grapple bars, and you can kind of see the grapple bars in the center of the arm. Of course, we've highlighted Luca in bright red there, so he's easy to pick out. You can see how he's perched on the end of the arm reaching out to grab these big pieces of equipment. In the next picture, you can see a shot of him holding the grapple bars in position at their permanent stow place. This is the grapple bars that are going onto the starboard truss. And of course, Chris will be free flow, as you mentioned, and coming in to help bolt those down into place. And the third shot is just a similar position of the second grapple bars being stowed over on the port side of the truss.
So this is a real good example of the choreography, if you will, between robotics and the humans, obviously the two crew members that perform the spacewalk. And you talked about the training, but how much do you have an idea of how much you guys trained, knowing this was coming, how much you trained before they actually flew?
Absolutely. Well over a year ago, we started working on the detailed procedures. Of course, as you and I'm sure your viewers know, we spend a lot of time sussing out every single little detail, and we develop for the crew line-by-line instructions or procedures on how to perform these operations. So we started working on those well over a year ago, and then of course we started training the crew. As you probably also know, our crew members spend a lot of time traveling. So in between their various trips to Russia, Japan, Europe, we had training sessions with them here in the United States, and we taught them, first of all, generically how the arm operates, how to fly the Canadarm2, but then also the details of the specific task. And we use a lot of different facilities to do that. We did a lot of training sessions in the virtual reality laboratory together with the EVA crew members. They wear their helmets and they get to see a visualization of the space station. And with Karen at simulated arm controls, actually moving them around. And that's one of our biggest opportunities to rehearse it. We also use the neutral buoyancy laboratory, which has a mock-up of the arm, an actual operating hydraulic arm, and we practice maneuvering the crew members around in there. So all of those things together give us a chance to rehearse both that coordination that I was talking about earlier, but also to time everything out, because we need to know down to the minute how quickly all of these tasks are going to go.
Right. So you mentioned the VR lab. That's here at the Johnson Space Center in another building over in the Space Vehicle Mock-Up Facility. Another activity, of course, is, after they get up there, you guys aren't all together anymore in terms of face-to-face, that is. But they have a robotic simulator on board that they can basically rehearse as well, right?
That's right. We actually have a couple of different ones. One is called Robot, which actually has joystick hand controllers, just like the real Canadarm2 does, and the crew can actually practice moving around a virtual arm in a virtual environment. We also have a simulator called Doug, and Doug provides purely graphics, not an opportunity to fly a simulated arm, but an opportunity for the crew to step through or jump this arm and simulate flying it through the various positions. And so just recently, in fact last Friday, we held a session for Karen where she was scheduled for some time to go in and fly through the robotics procedure and revisit them and freshen her memory.
Right. Now, one of the things I want to mention to everyone is Laura works for the Canadian Space Agency. She has a mechanical engineering and aerospace engineering degrees, right? One of the things I'm fascinated by is I don't know if telerobotics is the right word, but typically when we have crew members on board, if there's enough crew members in terms of like U.S. members or over in the U.S. segment, I guess, that are robotically trained, you might have the two folks outside and you have a robotics person, and as we did back in Shuttle, we would have a backup robotics officer that could spell the person. If it's a long EVA, they take turns, right, over or they train for different tasks or take turns. I guess for this one, the thing I'm fascinated by is Karen has no backup on board, so her backup is sitting right here next to me, and so I want you to describe, with your background, this has got to be something that's maybe like the Super Bowl for robotics, is getting to operate an arm that's circling the Earth 250 miles up.
Absolutely. That's by far my favorite part of my job, is that we do have the capability to operate Canadarm2 and of course Dexter, which is the two-armed robot, from the ground. And for a lot of our operations, moving pieces of hardware around, swapping out various payloads, we do that completely 100% from the ground. So the crew might go to sleep one night, wake up the next morning, and the robot is in a completely different place from where they left it, which is, I'd always like to go and tap on the window and look inside, but we're not quite at that stage. But it's a lot of fun, and you're right, it's very surreal to be able to sit here in mission control and send commands and move this enormous robot way up there on the space station.
Right. So as Karen's backup.
Now for this EVA, we won't actually be moving the arm from the ground. Obviously when you have a crew member on the end of the arm and the time pressures of a spacewalk going on, you want to make sure everything goes as smoothly as possible. So it will all be Karen moving the arm. Unfortunately, she won't have anyone to spell her off. But that second person performs a lot of checks. They're making sure that the cameras are set up the way you would need to monitor tight clearances or tough positions that you're getting into. They also make sure that appropriate software files are loaded for the command parameters for the arm. Additionally, when we move the arm, a lot of the time we move it using joysticks, but a lot of time we'll also type in a final position that we want the arm to maneuver to and essentially press a big go button, and the arm will maneuver to that position. And of course, as you can imagine, making sure you type in that destination position accurately is a very big deal.
Right.
And so that is the kind of thing that the backup person, what we call the M2, would do. And so we'll be performing those functions from the ground. So there'll be various points in the procedure tomorrow where Karen will be holding and waiting to get a call from myself through the Capcom to say, yes, that destination looks good, or the appropriate file is loaded, you're go to proceed. And so that's how we'll be doing that function from the ground tomorrow.
Great. So quite a bit of choreography between the ground. You may not hear it on NASA TV, but through the flight director, through Capcom up, so you'll hear a lot of interaction, not only between the EVA officer, Ernie Bell, obviously, and his team, but also with you and your team as well.
That's right.
So it's a very intricate process, and obviously robotics is a big part of what you'll see tomorrow. And Laura was kind enough to take a few minutes, as she is on duty in the room right now on this shift. So she's on until 3:30 this afternoon. So it was great of you to stop by and describe what's in store for tomorrow, and we're looking forward to seeing it all. Thanks a lot for coming by.
So am I. My pleasure.
That's Laura Lucier. She's the robotics officer here in the room on the current shift, and she'll be on duty tomorrow throughout the EVA that Chris Cassidy and Luca Parmitano will perform beginning just after 7 a.m. by the schedule on Tuesday.
Station Houston, Space to Ground 2 for Karen.
Go ahead.
Hey, Karen, we have the answer for you regarding the SSCs. Luca's helmet cam will be on SSC 5, and the GEM external cam will be routed to SSC 16.
Okay, great. Thanks for checking for me.
You're inside the U.S. airlock Quest with Karen Nyberg. She's serving as flight engineer number 6 of Expedition 36 aboard the International Space Station. She is on her first long-duration voyage aboard the International Space Station. She served as a crew member aboard STS-124, the flight of Discovery, back in May of 2008, that delivered the Japanese laboratory Kibo to the International Space Station. Quest is the uniquely shaped module aboard the International Space Station that serves as the departure and entry point for U.S.-based spacewalks, or EVAs. Quest was delivered to the station aboard Space Shuttle Atlantis back in July of 2001. So Quest is just about to celebrate its 12th birthday as a component of the International Space Station. During the spacewalk, as you heard Laura Lucier describe, in terms of the robotics function, Karen Nyberg will be serving as the intravehicular crew member for the spacewalk, essentially following along with the timeline, and she'll also be controlling that Canadarm2 from a robotics workstation in the U.S. laboratory Destiny. The workstation is for the robotic arm is actually located in two different places. There's a robotic workstation inside the cupola as well, but for tomorrow's EVA, the plan is for her to operate the Canadarm2 from the robotic workstation in the lab, using for visuals a series of displays in front of her hand controller for the Canadarm2, which itself was delivered to the station as part of the assembly process back in April of 2001 aboard Space Shuttle Endeavour. The Quest airlock is comprised of two major portions or sections. You see Nyberg in the equipment lock area, which is essentially a much larger diameter, 15-foot diameter section of the airlock, where the suits themselves are housed, recharged, basically reconditioned for each spacewalk. And there you see in the far distance a much more narrow cylindrical section of that airlock, which itself has a hatch that can be closed once the two crew members have completed their suit up, which Nyberg and Fyodor Yurchikin will help support tomorrow morning in the early hours after the crew wakes up and gets ready to begin the EVA preparation work. That crew lock can be sealed off from the rest of the station, and since it's so small, depressurizing it with the hatch closed allows the rest of the space station to remain at basically the sea level pressurization, which is about 14.7 pounds per square inch. They do perform a pre-breathe protocol that allows them to reside in the either on masks or in the equipment lock portion of the station as well, and reduce the cabin atmosphere somewhat to allow for a much more reduced period of time before they head out to begin the spacewalk. So as you heard Laura Lucier mention, there's a great deal of planning that is prepared for in terms of scheduled spacewalks aboard the station, as crew members that know that they are going to perform a spacewalk during their increment or their expedition on the station can actually plan for that far in advance. Obviously, there are occasions where a spacewalk that is unscheduled may be required periodically for a failed component that needs to be replaced. But those types of spacewalks are considered, for the most part, a generic type of EVA that is a standard protocol and a training template for crew members before they fly to the International Space Station for long durations.
Moscow ISS on Space to Ground 1. Go ahead, Sergey, this is Alexander. I'm starting the treadmill testing.
Принято, спасибо.
Copy, thank you. Okay.
As Chris Cassidy and Karen Nyberg continue work in the crew equipment lock portion of the Quest airlock, the ISS, the station is just about to cross the coastline of Morocco from a 250-mile vantage point, heading into a orbital sunset here in about 10 minutes or so as it traverses the entire continent of Africa from northwest to southeast in about 10 minutes. The crew members have a series of, in addition to their medical checks, they also have their private medical conferences with the ground. They're also scheduled for afternoon physical exercise of particular importance, obviously, to the two spacewalking crew members, but all crew members are timelined for physical exercise twice a day in the morning session, morning half of the day and the latter half of the day as well. Then before the crew conducts its afternoon daily planning conference with all the flight control teams on the ground, Nyberg will conduct essentially a software setup for her displays associated with the robotic functions that are scheduled throughout the spacewalk Tuesday as well. So she will essentially, that's the last task for her, is to essentially set up those displays ahead of time so that she can be prepared for the robotic functions tomorrow, so that her early hours can be used to concentrate on suit-up activities, running through the checklist to ensure that Cassidy and Parmitano's suits are in good working shape. When they head outside, they themselves essentially become individual spacecraft. The extravehicular mobility units, which have a mass in space of about 250 pounds or so, essentially provides everything that crew members need to protect them and provide all of the life support needs of the crew members while they are conducting these spacewalks. That includes oxygen, that includes carbon dioxide removal, obviously electrical power for the suits as well. And they have individual controllers to allow them to control the temperature inside the suit, since temperature excursions can extend from minus 200 degrees to plus 200 degrees on the outside of the station when it's in sunlight and in darkness. So the crew members have the ability with their liquid cooling undergarments that essentially allows for water flow through an elaborate intricacy of tubes that run through those suits to regulate that water flow to either heat up the suit when they're on the dark side of the Earth, or allow more water to flow to cool the suit when they're in the sunlit portion of the day. And of course, that occurs every 45 minutes during an orbital period of about 90 minutes as the station circles the Earth. Again, their spacewalk is scheduled to begin a little after 7 a.m. Central Time Tuesday, 8 o'clock Eastern Time. We will cover that EVA end-to-end, beginning with NASA television coverage at 6 a.m. Central, 7 a.m. Eastern Time. And again, they have a whole series of tasks associated with the spacewalk. It will be the fifth for Chris Cassidy, and the first, of course, for Luca Parmitano. And the tasks, as you heard them described by Ernie Bell, consist of a whole series of items for the crew members that you see there. There'll be removing and replacing a space-to-ground transmitter receiver that's failed on the stations outside. Missy is a materials ISS experiment that is on the outside of the station. They'll be bringing that in and working through some of the starboard radiator grapple bar installation, power cable routing from the U.S. node Unity over to one of the pressurized mating adapters. Some of this is to prepare for that new Russian laboratory that's scheduled for launch to the station later this year. So the overall plan and task that you see there are scheduled and timelined to last about 6.5 hours for those two crew members. And of course, we'll have it all right here on NASA TV to cover that spacewalk aboard the International Space Station by Chris Cassidy and Luca Parmitano, with inside assistance by the other 4 crew members throughout that spacewalk, with coverage scheduled to begin at 6 a.m. Central, 7 Eastern Time, so be sure to tune in for that. So until then, tomorrow morning early for the spacewalk coverage, and we'll be back on Wednesday for our usual hour of coverage of activities aboard the International Space Station and the voyage of Expedition 36. This is Mission Control Houston.